Okay, so moving on, we're still going to continue with conversions, but now we're going to add a little bit more difficulty to the unit, and we're going to begin working with compound units. And that means that we have 2 units designated per one number that's given. So there's a top unit. This always is on the numerator, okay, and the bottom unit has to stay on the denominator. So this unit here that is written on top will always stay with that number as you write it, okay? And so that unit of the gram is on top. So if I want to get rid of the grams, then I would put something on the bottom for a conversion factor to get rid of that, okay? So gram over a gram cancels out, equal to 1. Okay, so here we're going to convert grams per mil to grams per cubic centimeter. Okay, so you can see the grams are not changing, so we don't need to worry about canceling out grams here. We're not going to put any grams on the bottom here because we don't want to cancel grams. We want the grams to stay in there. Okay, so the only thing we need to look at is milliliters to cubic centimeters. Okay, so we just need to know our conversion factor for that, and we previously have learned that. So 1 mil is equal to 1 cubic centimeter, so basically it's a super easy, switch change there. Okay, but how would we put this in to actually show how it cancels out? Okay, so these are equal to each other, so if I put them on for a fraction, they're equal to 1, right? And so my 1 milliliter, which I want to get rid of, I'm going to put on the top here, so that cancels out with the 1, there's really 1 mil there, okay, per 1 cubic centimeter, and that's equal to 10 grams per cubic centimeter. Okay, so we're going to take a look at a few more problems where we're changing both the top and the bottom units for a conversion. Okay, so now we're going to take a look at a conversion problem where we have compound units and both of them are changing. So here we have 25 miles per hour, and we want to know how many centimeters per second are in 25 miles per hour. Okay, so what you want to look at is you want to look at just the numerator units, because you're going to convert miles to centimeters, okay? And then you want to look at just the denominator units. You're going to go from hours to seconds. So I'm going to first take a look at how can I go from miles to centimeters. Okay, well I know I can look up, if I don't already know, how many feet are in a mile. So I can go from miles to feet. And then I know how many inches are in a foot. And then I can use the previous conversion factor of inches to centimeters like we did in the previous problem. Okay, and that will get me to my centimeters. And then I want to make a roadmap for the denominator units as well, just like I did for the numerator. Hours to seconds. Okay, well, some people might know right off the top of their mind how many seconds are an hour, but if you don't, right, I know I can go to minutes. I know there's 60 minutes in an hour, and there's 60 seconds in a minute. Okay, and so that will be my conversion factor I can get to for the denominator. Okay, so I want you to take a few minutes and use this information here. You might need to look up some of the numbers in the back of your textbook. And what you're going to do is you're going to start with the numerator or the denominator unit that you're going to change. And I would recommend that you work through the entire numerator unit or the denominator unit all at once. And then you're going to come back and you're going to pick up in your calculation and work through the denominator unit or the numerator, whichever one you didn't do yet, and then work the rest of the way the problem through that unit to pick back up to convert it. Okay, so I want you to go ahead and try that for a few minutes on your own, and then whenever you're ready, you can continue on in the video to see the work laid out. So I'm going to work through the numerator unit first by converting miles to the centimeters. Okay, so I'm just going to leave the hours alone on the bottom, and I'm just going to focus on the miles. So I'm going from miles to feet in my first conversion, and I've looked up that 5,280 feet, which I want to go to the top unit because I want to get rid of miles per 1 mile on the bottom. Those are going to cancel. Now I'm at feet, right? Now I want to go to inches, so I'm going to cancel out my feet. 1 foot is equal to 12 inches, so the feet are gone. Right? And the next, now I'm going to go from inches to centimeters. So 2.54 centimeters on my top unit. That's what I want to go to. I want to put that on top, and I want to cancel out the inches. So I want those to be on the bottom. And again, each of these conversion factors is equivalent to the other. So the top unit is equal to the bottom unit, so it's equal to 1. And that's why I can flip it on the numerator or the denominator. It doesn't matter where, as long as, you know, I'm putting it in the right spot so that my units cancel out for how I want. Okay, so now I have centimeters on top. I'm done with the conversion for the top unit. Now I'm going to come back in the calculation and pick up my hours. Okay, so I'm just going to kind of continue on in my calculation here. The first step is I'm going to go hours to minutes. So I want to get rid of hours. That's the larger unit. So 1 hour, I have the smaller unit, 60 minutes in an hour. My hours are gone. And again, I'm changing the denominator, so the unit should be changing on the denominator, okay? And now I'm going to go from minutes to seconds. So 1 minute has 60 seconds. And I have arrived at the units I want on the denominator, seconds here, so I'm done. So now I just have to plug all these numbers in my calculator. So it's going to be 25 times 5,280 times 12 times 2.54 divided by parentheses 60 times 60, end parenthesis, enter in your calculator, and you should get 1,117.6 centimeters per second. Okay, so I need to report this in the correct number of sig figs, and so I have 2 sig figs given in the original number here, okay, and so I need to convert this to the correct number of scientific notation. If you want to report it in scientific notation, or I can just round this 1,100 centimeters per second, or if you want to put it in scientific notation, that would be 1.1 times 10 to the third centimeters per second, right? Either one. All right, so we're almost done with some of our practice on our conversions. Here we're going to take a look at a word problem. It's a little bit more complicated, and you really need to formulate and put all the information together by first identifying and sorting everything, developing a plan, and figuring out what you're actually converting to. So starting with what you got, figuring how you're going to do your conversion to get to what you want. Okay, so in your handout that is provided along with this video, we have mass of jet fuel has to be calculated before each flight. That way you can calculate the mass of it and add that onto the total mass of everybody on board and all the luggage to make sure that the plane is going to be able to fly. Okay, this particular jet, you got a 747 jet, it's fueled with 173,231 liters of jet fuel. Okay, and we know its density. So the jet fuel has a density of 0.768 grams per cubic centimeter. And the question says, what is the mass of the fuel in kilograms? Okay? All right, so the first thing we want to do is we want to identify what are we starting with and what are we converting to. Okay? We're given a volume of the jet fuel. So we want to know how much does this volume of jet fuel weigh? That's the main question. How much does this volume of jet fuel weigh in kilograms? Okay? Another thing that you want to recognize, it's really, really important because it will really be helpful in developing a plan, is you want to recognize what type of unit you're starting with and what type of unit you're ending with. So I'm starting with a volume, okay, and I'm being asked to convert it to a mass, okay, and I need to do some type of plan here, a conversion factor to convert my volume to mass. Mass to volume, volume to mass. We did talk about that already, and so you want to think, oh, I know the physical property that correlates those two together, and that physical property is, yes, the density, right? So my conversion factor is going to have density in there somewhere, okay? All right, so let's think about our plan. Okay, so if I'm going to use the density to help me get from volume to mass, right? My liters is related to my cubic centimeters. I can go from liters to mils and then mils to cubic centimeters. Then I can use this density in there to get me over to mass, which would give me grams, but then I just need to convert a prefix using the prefix from grams to go to kilograms, right? Okay, so let's kind of outline that plan here so we can see it. And it's so important that you do this plan before you just start putting numbers down and trying to write down conversions. Okay, you really need to kind of think through it and develop the plan. Otherwise, sometimes you just end up going in circles and you don't go anywhere. Okay, so I'm going from volume, and I need to use the density in my conversion factor because that is the physical property for this specific information about this fuel that will allow me to convert the volume of it for how much it weighs. Okay, so I need to get to cubic centimeters from volume, right? And I know I can use mils. So I'm going to go liters to milliliters, and then milliliters to cubic centimeters, okay? And then I'm going to use the density information, okay? And here, and whenever I put that in there, it's going to cancel out my cubic centimeters, okay? And I'm going to end up with, on the other side, the grams, because my cubic centimeters are going to cancel here when I put that number with those units in there. So I'm going to end up with grams on the other side of that, and then I just can use a prefix and convert that to kilograms. Yeah? Okay? So there is the roadmap for you. So go ahead and take a few minutes, okay, and try to plug all the information in there before you watch the answer. So let's work the answer out together here. So we're starting with 173,231 liters, and I'm going to use my prefix. I have 1,000 milliliters is equal to 1 liter. Those cancel out. And now I'm moving on to convert my mils to my cubic centimeters as outlined in my plan. 1 cubic centimeter is equal to 1 mil. My mils cancel out. And now I'm at cubic centimeters, and I can use my density here, using the information of the density up here, to get rid of my cubic centimeters, okay? So here's where I'm going to be using the rest of the information in the problem. So remember, the number that's given with the unit always stays with the top unit. So the cubic centimeters just has like a 1 with it on the bottom. Okay, so this is really like 1 cubic centimeter on the bottom, and the number 0.768 goes with the top unit. That's the grams. Okay, and so now my cubic centimeters cancel, and I'm in grams, but I need to report that in kilograms. So just continue on using my prefixes. So kilo is larger, so that's 1 kilogram. Gram is smaller. I need 1,000 of them. My grams are canceled, and I end up with my kilogram, which is my final unit that I want. And I can calculate in my calculator. I'm going to plug this number times this, divided by 1,000, and that will give me some numbers. 1.33 times 10 to the 5th kilograms. And I have my density in only 3 sig figs, even though this is the measured value. That value is used in the calculation, so that's why I'm going to limit reporting my answer in just 3 sig figs here. Okay, and so 1.33 times 10 to the 5th kilograms, that's a lot of mass, and that's a lot of fuel, so it makes sense, at least if I look at that to see if it could be correct.